Thank you. My name is Petr. I'm from the Czech Aerospace Research Center in the Czech Republic, and I would like to present to you some results of evaluation of the effect of primer and sealant in the refill friction staple welded joints on a strength and fatigue behavior of some chosen aluminum alloys. This presentation and works were done in the frame of the Oasis project funded by the European Horizon 2020 Clean Sky 2 research program, and Oasis is acronym for Optimization of Friction Stir Welding and Laser Beam Welding for Assembly of Structural Aircraft Parts. These 7 project partners were involved in the project that was led by the topic manager Saab from Sweden and coordinated by TWI from United Kingdom. The overall objective of the Oasis European project was to demonstrate the ability and cost effectiveness of manufacturing aluminum aircraft structures using the latest developments in friction, stir and laser beam welding, with aim of fabrication of structural aircraft parts in aerospace grade aluminum alloys for replacement of existing riveted solutions. Joining using rivets is more time consuming than using welding approaches, enabling improved aerodynamics and lightweighting, which subsequently will improve fuel efficiency and the global competitiveness of the industry. Here you can see positive features for the first time from the weight saving potential. It's elimination of overlapping flanges and fasteners and reduction of material thickness through improved stiffness and joint strength. And from point of view of cost saving potential, it's reduced raw material volume, no fasteners, and reduction in processing time. Here you can see only example of quick estimate of estimated total weight reduction for Airbus A350. The refill friction stir spot welding is one of the promising methods, consisting in the joint creation by plunging and retracting the rotating tool into the overlapped sheets. Main advantage of this method is that this process doesn't leave an exit hole after welding, like here, and is able to provide a larger area weld, resulting in improved weld strength. The principle of this welding method will be shown in video presented later on. Regarding the objectives of these works, it was to fulfill a knowledge gap related to use of aluminum semi-products in final configuration state for a refill friction stir spot welding process by means of the lap shear and cross tension mechanical test, and these states means including anodizing primer and sealant application. Then the effect on static strength for joint configuration with primer and sealant was studied and compared with the bare materials refill friction spot weld joints. And main goal was to obtain data for the specific design production of the technology demonstrator 1 in the form of cargo door representative for Airbus A320 single aisle. You can see here. All refill friction stir spot weld trials were done at TWI using this Kawasaki robotic system with 6-axis articulating arm and C-frame design, and with force range up to 15 kilonewtons. And the system was equipped using this tool made of metal matrix composite and with diamond-like carbon coating. So by this method, over 200 welds have been produced for mechanical testing in the form of lap shear test samples, shown here, and cross tension samples. Two main materials were used for the samples manufacturing. The first one representing the frame was aluminum alloy 7050 of 2 mm in thickness, and the second one 2024 with thickness of 2.8 mm representing the skin. We used 5 baseline coupon configurations, 3 with no interface. So the first one was 7050 7050, then 2024 2024, and then one dissimilar spot weld configuration, and then 2 configurations, one 7050 7050 that were anodized, primed, and with sealant, and the second one 7050 2024 with sealant was the similar one. And moreover, 2 batches without the primer application in the welding area were used, and again in 7070 and 7020 variation or configuration. Regarding the test methods, all tests were done at room temperature. The lap shear strength test was done according to European ISO standard 14273 under a displacement rate of 0.25 mm per minute. Always 3 specimens from each configuration and be tested, and DIC digital image correlation analysis using Dantec system was used for strain distribution evaluation. The lap shear fatigue testing was done according to European standard 14273 and 6072. And the constant amplitude hammer loading with Simpson shape of the loading cycle, and the load control at test frequency of 15 Hz and stress ratio 0.1, so it means tension mode. And static cross tension or pull out test were done according to European 14272 standard under displacement at rate of 2 mm per minute using 3 specimens from each configuration. The test results are presented here in graphical form. It's evident that configurations with primer and sealant showed an evident decrease in strength as compared to the bare condition samples. And if we compare the configurations with primer sealant with no primer test batches, we can see a significant improvement of mechanical properties in case of primer-free configuration. And if we compare the results with the requirements or specification from Aerospace Industries Association and American Welding Society for the lap shear strength of the solid aluminum rivet 2024 in state T3, we can see that the bare configurations and the primer-free configurations have no problem to meet these requirements values, whilst these 2 configurations with primer have problems to meet the requirements of this specification. A worse behavior of primed configuration was confirmed also by means of DIC measurement. You can see a comparison of the DIC maps during the lap shear test for 2 7050 and 2024 configurations, so bare versus primed, and you can see a different strain distribution around this weld joint, where a typical butterfly shape instead of in a primed configuration you can see only stress concentration or strain concentration around this weld zone. Also, a metallographic analysis performed on cross sections of primed and primer-free 70-50-70-50 configurations show that there are differences in weld nugget appearance. You can see here the primed version. There is a remnants of primers at the interface of both top and bottom sheet, and this weakens the joint, of course. Whilst in case of primer-free configuration, there is only a small ligament of sealant inside the nugget zone. Here you can see the fatigue test result summary. In this plot you can see that the primed configurations exhibit a high scatter of the results and a different slope of the fatigue curve as compared to the bare configurations. This is due to clipped edges effect due to a sticky sealant joint. And also from this comparison of the configurations with primer and without primer, it's evident that the fatigue behavior improved in case of no primer batch, exhibiting a higher slope of the fatigue curve with almost no effect on fatigue limit. So these are the main results of this experiment, and here you can find everything again in this summary. More you could find in the paper that there is under preparation now. Thank you for your attention.